Viscosity. So what is viscosity of the liquid or any fluid? Very simple, students. Let us we consider a small pipe which is kept horizontally. We assume that the liquids are going layer by layer. So it is going layer by layer. So liquid is flowing from one end to another end. So in this direction, this is a flow direction, this is a in. So it will get into the pipe, it will be outlet. Okay, so we assume that this bottom layer, so this bottom layer is a solid layer. Okay, so this bottom layer is a solid layer. So what about the friction between this first layer and the bottom layer? So there will be a friction is more. So let us assume that this is the bottom layer, the one layer, liquid layer is going with, there will be a friction will be more. That's why this liquid layer will fall down immediately. Then if you assume that the second layer, so what about the position of the second layer? The second layer is move over the first layer. So compared to this bottom surface, this surface is more smooth than one. So this second layer will slide more faster than the first one. Then the velocity is increased. Okay, then the velocity is increased. That's why the flow will be more than that. The position of the liquid layer falls on the outside the pipe will be second layer is more than that of the first one. Similarly for the third layer, so what will happen? The movement is more further smoother because already this second layer is in motion. So again the third layer will move. So this layer is more smoother. So the velocity will be increased and it will be fall down. Likewise, the velocity increases, then the upper layer will fall down like this. This is the reason why in a pipe the liquid or not come and fall on the same point. It will come out like this. So this is the reason. So what is viscosity? Come to the conclusion. So the viscosity is defined as there is a relative motion between the two layers of the liquid. There is a relative motion between the two layers of the liquid. That relative motion will be opposed by a force is called viscous force. So viscous force means a force which opposes the relative motion of the two liquid layers. That viscous force will reduce the velocity of this liquid layer's motion. Hence we can say that more viscous liquid has a less velocity. Compare the water is a less viscosity liquid and the oil is a more viscous liquid. So oil will flow very slower than the water. So water will flow faster, oil will flow very slower because the viscosity is high. That means the viscous force is more for oil. Viscous force means which will opposes the flow of the liquid layers in the oil. That's why the oil will flow slower than that of the liquid. So I will define that. What is the viscosity? So viscosity is a property of the fluid by virtue of which an internal force of friction comes. Internal force of friction. There is a friction between this layer and that layer comes to play when the fluid is in motion, which opposes the relative motion with its different layers. So this backward dragging force is called viscous drag. This backward dragging force is called viscous drag or viscous force. Acts tangentially to the layers of the fluid in motion and tends to destroy the motion. That means that will reduce the velocity of the motion. So this is the reason for why the liquid will flow slower for the high viscous liquid and low viscous liquid. So viscosity is defined as there is a relative motion between the two layers of the liquid. That relative motion will be opposed by a one force. That force is called viscous force. This phenomenon is called viscosity. This phenomenon is called viscosity. Now we are going to next topic is we are going to find what is the coefficient of viscosity. What are all the factors that the viscosity depends on that. Coefficient of viscosity. So what is the coefficient of viscosity? So the coefficient of viscosity may be defined as a tangential viscous force required to maintain a unit velocity gradient between its two parallel layers each of unit area. So very simple students. So first we have taken the area, layer of liquid which has the area A. There is the same area, the layer is just above this bottom layer. P is the first layer and the Q is another layer. The distance between these two layers is dx. So this is the ground surface. From the ground surface, this layer, P layer, this is one of the liquid layer whose area is A. There is another liquid layer is Q whose area is A. So the distance between the ground, that is the bottom surface, and this liquid layer is x. Then for this Q layer is x plus dx. The bottom layer is moved with the velocity v. Then the uppermost layer will move with the velocity greater than this bottom layer. Hence we can take that v plus dv. dv is a extra velocity than that of the bottom layer because of the relative motion between these two layers. The friction is very less between these two layers because the second layer slide over the first layer. The first layer is very smoother, but this layer velocity is greater than this layer because this P layer, the liquid layer P, will slide over the ground. So the ground is a more friction than the friction between P and Q. Hence the velocity is lesser. So that and all things I have explained already in the previous sections. So there is a two liquid layers P and Q which moves the velocity v and v plus dv, and the distance between them is x and x plus dx respectively, whose the area of P and Q liquid layer is same. Area is same. So we can say that there will be a relative motion between these two liquid layers will be opposed by one force is called viscous force. That viscous force is directly proportional to area of the liquid layers. That viscous force is directly proportional to velocity gradient. Velocity gradient. So gradient means distance. So the any physical quantity which changes with the distance means that is called gradient. Here the velocity is changes with distance. How? Here the velocity is v. As the distance increases, the velocity also increases. The velocity changes. Hence we can say that dv by dx. So that is a change in velocity with respect to distance is called velocity gradient. So that viscous force is directly proportional to velocity gradient. As we move above the ground, the velocity is increases. Then we can say that the viscous force is directly proportional to area and velocity gradient. This proportionality removed by a constant is called coefficient of viscosity. This constant is called coefficient of viscosity. We can spell this as eta. So we can spell this symbol as a eta. Force which is equal to coefficient of viscosity eta area into dv by dx, that is a velocity gradient. What is this minus sign? Minus sign indicates that the force, this viscous force is opposite to the direction of motion of the liquid. The motion of the liquid is in this direction. Viscous force direction is opposite. Hence we can put a symbol minus. So what is the coefficient of viscosity? You have to bring all those things to the left side. So F by A into dx by dv. So this is the coefficient of viscosity. That is we can define as coefficient of viscosity of the liquid may be defined as the tangential force. This is a tangential force required to maintain the unit velocity gradient. If the dv by dx, that is the dx by dv is unit, we can write this one as a dv by dx here in the denominator itself. So in order to understand purpose, I will write it as a dx by dv in the numerator. So this value is 1 unit velocity gradient. This value is 1, and the distance between, that is the area, is unit area. The liquid layer area is 1, means this eta is equal to viscous force. So viscous force is defined, coefficient of viscosity is defined as a viscous force in which the velocity gradient is 1 and the area is 1. What is the SI unit of velocity coefficient of viscosity? 1 Poiseuille. What is the CGS unit? 1 poise. So 1 Poiseuille means force is Newton, area is meter square. So I will take this as a dx by dv. So dx is a distance meter and v is a velocity meter per second. So if you cancel these things, we get an answer 1 Newton second per meter square. That is a meter power minus 2. This is a SI unit of coefficient of viscosity. Then for CGS unit, instead of Newton, dyne, second as it is for meters, centimeter. So dyne second, centimeter power minus 2. The relation between the Poiseuille and Poise, CGS SI unit and CGS unit is 1 Poiseuille is equal to 10 Poise. So the coefficient of viscosity is, this is a simple derivation. So this may be asked in 2 more questions. Draw the diagram and explain clearly.